Okay, so now we're ready to officially define what a polynomial is. And basically what a polynomial is, it can start off as just a single term. That sounds like an oxymoron because we all know poly means many, and actually nomial means number, so we're talking many numbers. But by definition, it is a single term, and I'll explain why we can get away with that. But a polynomial is basically a single term, right? Or the sum or difference of many terms. Alright, of course sum means we're adding and difference means we're subtracting. So essentially what a polynomial is, it's just basically taking terms and adding and subtracting them. And of course that's what a term, I think way back hopefully in a 092 class you learned that terms are things that we add together. And so we're basically, or subtract, and that's basically what we're having here. So it's a single term by itself or many of them strung together. And so for example I could have just the 2, right, all by itself, or the 2x all by itself, and technically speaking I have a polynomial. Reason being is because, right, I've just made it many, right? I can add 0 as much as I want, right? So I know that's a little sneaky on a mathematician's part, but that's how we get away with the fact that, okay, I have a single term, but technically we're adding a bunch of zeros to it, all right? And so there's your many. So that's how we kind of get away from that. But looking more at sums and differences, getting a little more creative with that, right? So we have something like 5x plus 3, all right? So this also is a polynomial because I'm taking the sum of a term and another term, and hence we have what we famously know as a polynomial. Maybe I have negative 2x squared plus 5x minus, let's say, 7. All right, and so this would be another example of a polynomial because I'm basically adding and subtracting. There's a term, there's a term, and there's a term. So in this case, we have 3 terms. And so we're basically adding and subtracting them. And we can just keep building on, right? So maybe I have 7 halves x cubed, right, plus a 10y to the 4th, right, minus, let's say, x, right, and then plus, let's go with 2. All right, and so there's basically another polynomial. This time I have 4 things in it, and so we're adding and subtracting them. That's a term, that's a term, that's a term, and that's a term. So polynomial, all right? So the idea is we're adding or subtracting a whole bunch of terms together, all right? And then with that comes other definitions. The first one I want to go over with you is this concept of descending order. This is a really important thing to do because you can identify the next couple of items if you're in descending order relatively easy. And basically what descending order means is we arrange our, or how about I just say the polynomial from highest degree term to lowest degree term. Okay, so that's what it means to descending order. We're arranging the polynomial from highest degree term to lowest degree term. So let's go take a look at my 5 examples. So obviously these guys are kind of trivial. They're the only term, so it's obviously in descending order. It's the only one there. But if you look at this 2-term polynomial, right, notice it is in descending order because that term is degree 1, right, the coefficients of the first power, and this is degree 0. Recall there's an x to the 0 power there. So I'm in descending order, a degree 1 term followed by a degree 0, descending order. Same with this 3-term polynomial, right? It starts with degree 2, and then a degree 1, and then a degree 0. So this is in descending order. And then this 4-termer is a little off, right? Because this term right there is a 4th degree polynomial, a 4th degree term, and then we have a 3rd degree term. So this is not in descending order. So perhaps what we'll do is rewrite this as 10y to the 3rd plus 7 halves x to the 3rd minus x plus 2. And so what we basically have here, right, is this, that's to the 4th power. we now have something that's in descending order. A degree 4 term, followed by a degree 3 term, followed by a degree 1 term, followed by a degree 0 term. So descending order, great habit to get into. It helps when we multiply, it helps when we divide, helps when we add and subtract. So very good skill. Just when you see a polynomial, put it in descending order. All right, because that basically gives the next two things. The first thing is this item called a degree of a polynomial. This is different than the degree of a term that we defined in the last video. The degree of a term is just the power on just the variable part of each term. But the degree of the polynomial is the highest, all right, degree term. So when I look at this, and this is why descending order is so important, right? This would be a degree 4, all right? So this is a degree 4 polynomial because the highest degree is 4. And because I put it in descending order, it's sitting kind of out here in front, so we don't have to guesstimate it. This would be a degree 2 polynomial because the highest degree polynomial is 2. Right? This would be a degree 1 polynomial, right? Because the highest degree term is 1. And this also would be a degree 1 polynomial because the only term in it is of power 1. And this would be a degree 0 polynomial, right? Because again, we have x to the 0 power. Okay? So that's what a degree of a polynomial is. It's the highest degree term that you got. If you put it in descending order, that highest degree is basically sitting right out in front because you're arranging it from highest to lowest. Then we have what's famously known as the lead coefficient. Now remember from the last video, the coefficient is basically the number part. All right, so the lead coefficient is basically the number part of highest degree term. And if you put your polynomial in descending order, you can almost see why we call this the leading coefficient, because there's my highest degree term. It's up here in front, so there's your lead coefficient. All right, essentially it's the first coefficient that we see because of the descending order. So my lead coefficient in this example would be 10. All right, here, oops, this is not descending order. Right here, the lead coefficient would be -2. All right, not 5. Right, we're not talking about the highest coefficient. We're talking about the number part of the highest degree term. So if I'm in descending order, there's the highest degree term. So the leading coefficient is sitting right out here in front. The number part of the highest degree term. This is a lead coefficient of 5. All right, because here's the highest degree term and the coefficient is 5. These guys right here, there's only one term, so in both, I'll just cut to the chase, the lead coefficient is 2, right? Because it's really the only coefficient that I have since it's a 1 degree. All right, so there's basically 4 more things to identify. The idea of what a polynomial is, a single term by itself or sum or difference of terms. Descending order, that's when I arrange my polynomial from highest degree term to lowest. The degree of the polynomial is basically the highest degree term that I have. If you put it in descending order, it's basically the degree of the very first term. And then the lead coefficient, right? That's basically the number part of the highest degree term, which again, if you're in descending order, is out in front. It's leading. All right, so that gets us ready for the next topic of polynomials. And so far we have, what, 7 things identified: a term, a degree of a term, right, and a coefficient, and then a polynomial, a descending order, right, a degree of a polynomial, and then a lead coefficient. So 7 items. All right, more coming later. Talk to you guys in the next video.